Good evening, because it's 7 o'clock probably. I'm from the team third for the space dust, for the anti-space dust, and today we will talk about our system, which is called MOCLEDUS, which is a system to you can go on the next slide, which is a system who is developed to allow the removal of the space dust from the spacesuit after, for example, an EVA, extravehicular activity. And today we will talk about first of the development of the mission, starting from the work breakdown structure to the time schedule. Then we will introduce our idea, or we will like to test it, and risk and cost analysis, and then some conclusion. You can go on. So basically, here briefly the work breakdown structure of the whole project, developed according to the ESA CSS model. So you can see the feasibility, the design, the production, the verification and test, and the final verification phase. And now during the hackathon, we have developed only the first phase, so the feasibility, and you can go on to show also the work breakdown structure of this phase. And now you can go on. Basically, we start with an introduction to the problem. The basic idea is to develop this solution to avoid both problem with the human health and problem with the systems. For example, for the environmental control and life support system, we could have some problems, for example, for the filters or for the environmental control. And the dust could be dangerous for both the electronic, because for instance, for the optical devices could be dangerous to cover, for example, the mirror, or for other instruments like the rovers or the moving parts. And of course, we have to develop a solution when the astronaut come from the outside to the inside of the habitats. You can go on. So that we have developed the statement, identify first the reason why we would like to develop our solution. What are the main objective of our solution? You can see to the main is to remove the dust from the spacesuit. The second is to develop procedure for the astronaut to avoid dust concentration, and finally the last one is the possibility to test it in both the lunar habitat and the terrestrial one. And you can see also the final user, the constraint imposed by the scenario, and also the way we would like to develop this solution. So basically it's the electromagnetic solution. And you can go on. Here you can see briefly the statement, but it's not very important. You can go on. And finally, here you can see the time schedule of the whole mission. You can see we are currently in the first phase, so the feasibility. And you can see, of course, in the last week of July, we developed this feasibility proposal. And if our, of course, our project will be accepted and will be selected, we go on developing other phases, and you can see the schedule during the month up to the February, when the Asclepius campaign will take place. And you can go on so that we can introduce our idea.
So, hello. Yeah, basically, when an astronaut having a long day exploring the moon and returns to the habitat, he need not to enter directly the airlock system with the dust on his spacesuit. So we have introduced an anti-dust chamber where the dust can be removed mechanically by using brush rollers as well as electromagnetic flow. Go on. Next slide, please. So here comes our prototype CAD model, where when an astronaut enters this candidus chamber, he have an electromagnetic floor in downside and air brush rollers on his sides. So this electromagnetic floor we are going because we can change the magnetic field as much as we want, and considering the safety of the astronaut. Uh, and the brush rollers, it looks like it can shred off the dust and that magnetic dust that can be collected on the floor. Uh, and these magnetic flow can consist of the solenoid, and here you can see the electromagnetic flow circuit. We can drive this. This is basically prototype we can develop by simple circuit. We can use MOSFET where the current can be driven and diodes so that we can control the magnetic field. Next slide. We need to consider how this will affect the astronauts. So we have like safety requirements as well as constraints. So basically, an astronaut can sustain up to 10,000 microtesla, and this magnetic field should not change. It should be a steady field. And the electromagnetic flow that the astronaut will stand should be constrained, and it should be very small, so that another can be not disturbed. And to have the perfect removal of the dust from the spacesuit, you need to stand at the center of the platform. Next slide, please. So we have taken the basic prototype, like a small area and with small radius. So we got the we got the magnetic field produced is around 0.5 milliteslas, so which is not more which astronaut can sustain. Next slide.
And here we can see a draft of the budget we considered for our proposal. So basically you can see two different budgets because we considered both the option to develop a solution only for the moon, the moon. So the final configuration for the use on the moon. And you can see that the total budget is roughly 3,500 of pounds. And the second solution is very cheaper. It's much cheaper. Is a budget based on the idea to develop only the solution for the test purpose on Earth. So basically during the Asclepius campaign, for example, and you can see in this case, the budget is very, very low, which is basically 100 pounds. And of course, the prices have been taken from the commercial streets. You can go on. And here, some final consideration, open point and future work. So basically, all the high-level requirement, the base high-level requirement imposed by the mission statement have been met. And the strength of our system are basically the low cost, as we have seen, the simplicity of the system. So the basic idea is very simple. We don't have any complex system. Of course, we use commercial components costs. So it's very simple. And of course, we can use this solution also for other proposals which are not related for space, for example. And of course, this system is not a huge system. We can also add other system to this solution, and we can develop a more complex solution using different subsystem. Open point, how to remove the dust from the floor, how to improve our solution, and how we can to get it more efficient, basically. And to do that, we will basically develop our system in a more complex way. We will, for example, develop the rover, as we said before. And basically we have to design also the space bus, which is basically the subsystem to support our system, for example, the APS, electrical power system, or other control system. And of course, we can to write also the procedure for the astronaut who enter in our habitat, and that's all. You can go on, and here you can see all the team. Thank you.
All right, great job. So at this time, of course, we will ask some questions for the next 5 minutes. And I will ask the mentors to start with the questions, and then students can follow after. But I will start with the first question. I like your presentation. I like your idea. But I do have one thing that's kind of poking me in the brain, if you will. And that is, if you're using these type of these rollers to clean the spacesuit, how much damage do you think it will cause to this spacesuit due to friction?
So, well, the idea of the rover, to be honest, we haven't developed it during the hackathon. It is only concept, a very early concept for the next iteration, basically. So we don't have any idea about the damage or the effect on the spacesuit. Also because we haven't developed any risk analysis on that. But I think that it depends on the materials of the spacesuit, for example, and it all depends on also to the technology that we will like to use for developing the rover. But I think that is not a very big problem, I suppose. But of course, we don't have any information about that because we haven't developed that simply.
Okay, thank you. Yes, in the future, you'll probably want to consider this type of
yes, of course. Yes,
this type of thing.
That's right.
Okay.
Thank you.
Of course, thank you. There are questions from our mentors.
Yeah, I have a question. How can the enclosed chamber cost only 30 pounds in the Asclepios case? I mean, the test purpose on Earth.
So basically, the anti-dust chamber has not to be considered on the cost because we can consider it, to be honest, we haven't checked it, but we consider it as a part of the existing habitat. Or we can, for example, to consider this habitat as a unflattable chamber, for example. In this case, maybe it could be possible to have, of course, an higher cost to the respect to the one we have found, basically. But I think that, for example, in this case, if we use an unflattable habitat, we can to keep the price very, very low. But of course, it has not be considered, honestly.
Okay, thank you.
Thank you.
I have a question. I'm Rashika. Firstly, thank you for the great presentation.
Thank you.
Okay, my question is, since you quoted the cost and power system requirement when you are using this system on the moon base, have you done any work on the rough order magnitude of power requirement and the primary source of power supply?
Not yet. It is an open point that we have to develop. Of course, the power budget has to be considered when we design the support system in this case. And of course, it could be a very interesting point related to the cost, because of one of the major problems is to design a solution for the power. But I think that in the case of the moon, we can to use, for example, the cells fuel to produce energy. In this case, I think that it will not be very high power consumption. So I think that in this case, we can consider it, for example, not very huge, the power using in the case of the moon. Of course, we have to study the problem.
Yeah, okay, fine. Thank you.
Thank you.
I have a question.
Mm-hmm.
You said you're going to use brush rollers. So, like, how will you clean other parts of the body, like the stomach area or the legs? Because the shape would be a problem.
Sorry, the materials for the other parts, you mean?
The other parts of the body. How will you clean the other parts of the body using brush rollers?
Yeah, actually, the stand that you've seen earlier, it won't just stay there. It will roll in front and back. So it can, it's like a kind of robotic arm. It can move front and back. So dust can be removed in that way.
How will you clean the stomach area, for example?
Sorry?
How will you clean the stomach area of the body?
Yeah, that's what I'm saying. Like you have seen earlier, you have stands left and right. So those are not fixed actually. Those can roll.
Maybe it's not very clear the question, but if I understand well, you mean how we would like to clear the rest of the body of the, for example, astronaut. In this case, I can say that the roller are bigger enough to provide the clearing capability to all the surface of the body. And if you mean how we would like to clear the floor, for example, in this case, we haven't a solution. We don't have a solution yet, but we can consider it, for example, the rover solution in the future as the solution for the problem. If I well understand the question, sorry.
Okay.
Okay.
Perfect.
All right.
Hello, I have a question.
Mm-hmm.
Okay,
Yeah,
last
so,
question.
Yeah, the dust gets removed by the rollers and it falls on the floor. So how have you planned to eliminate the dust which has fallen on the floor? Do you have any idea to remove it out?
At the moment, we have only concept of idea. We haven't developed an idea for that during the hackathon, to be honest. We can future develop this kind of rover to clear the platform surface. Or another way could be a mechanical way to clear in other way, for example, the platform surface, but in this solution we don't have any way to remove it at the moment. It is an open point.
Okay, because I was just concerned because when the dust falls on the floor and the astronaut moves into the airlock chamber, the dust could stick to his feet, the base of his feet. So yeah, I was just concerned. Thank you so much.
Yes, it's to be honest, the platform is magnetized, so it is a bit difficult to have the dust fly on the chamber because it stay on the floor by the magnetic force, for example. But of course, we have to remove it, of course.
Okay.
And so thank you.
Yeah.
If you have any question, you can write in Discord, I think, and we will try to answer to you.